Hey everyone, this is Kat, and I'm here to walk through worksheet number 2 with you, kind of as a supplement to checking answers with the key to give you some of the thought process behind this. So at this point, you have already completed worksheet 2, and now we're going to check on everything. So this is about the concept of the mole, and we're going to be using particle diagrams and reasoning based on what we've already discussed and looked at with the mole to support our answers. So taking a look at question number 1, we're going to draw particle diagrams representing equal amounts of moles for potassium and for calcium. So I'm going to use 2 different colors here. I'm going to make potassium green, and I'm going to make calcium purple. Before I do anything, I want to go ahead and start by looking up the masses on the periodic tables for these elements and express those as molar mass. So that's going to be in grams per mole. So when I look at potassium, this is 39.10 grams per mole. And then calcium is 40.08 grams per mole. Okay. Big important thing here is if we have the same number of moles, this means we're going to have the same number of particles. Now, it does not matter one bit how many particles you choose to draw. You just have to make sure that your 2 pictures, one for potassium, one for calcium, have the same number of particles. I'm going to choose to use 8 particles here. I'm going to start with potassium and put those in my container. I can see based on the molar mass that the calcium particles are a little bit more massive. So I'm going to try my best to show that they're a little bit larger, but I want to make sure that I am showing the same number. So again, I used 8 particles in my potassium, so I want to use 8 particles for calcium. Okay, great. So if we have the same number of particles, we want to know in question number 1, will the mass of calcium be less than, greater than, or equal to the mass of potassium? So if we have the exact same number of particles, and if we look at the molar masses, this is where we want to look for our answer. Because the mass of calcium for 1 mole is greater than the mass of potassium, then we know that for our sample of equal moles, that its mass is going to have to be greater. Okay, so we're going to say that this is greater, and that's because of its molar mass. Molar mass is larger. Oops. Okay, great. So how must atoms of potassium and calcium be similar or different? And explain our reasoning based on our previous answer. So they're the same number. We show the same number of atoms. So that's a similarity. But the difference is going to be based on the size. Calcium atoms are going to be slightly larger based on their slightly larger mass. And remember, while we find these numbers on the periodic table to use as molar mass, they really are actually also telling us the atomic mass, which is the mass of 1 atom. It's just the difference in the units. And again, these are related between the relationship of carbon-12 being the basis of the number of particles in a mole, as well as the basis for our atomic mass unit. Okay. Let's take a look at questions 3 and 4, which is going to be looking at magnesium and zinc. So just like I did before, I'm going to choose a couple different colors to represent these. Magnesium's already represented in gray, so I'm going to go ahead and keep that. And let's do, I don't know, green, or I already used green. Let's do blue for zinc. Okay. I'm going to look up their masses on the periodic table. Magnesium is 24.9 0.31 grams per mole. Zinc is 65.39. Okay, so we want to start out by having an equal number of moles for each of these. So again, I'm actually going to start with my explanation that we already talked about on the previous one. And I'm going to make this short and sweet. Equal moles is going to mean that we have the same number of particles. In this case, because they're both elements that are monatomic, this is going to be atoms. Okay. And then if we look at these molar masses, we can see that the molar mass, which I'm going to abbreviate MM, molar mass of magnesium is less than the molar mass of zinc. Therefore, zinc atoms are larger. Okay, so that's exactly what I want to show. If I count up my number of particles, I have 8 atoms of magnesium, so I want to have 8 atoms of zinc. Okay, and again, I'm going to make those a little larger. What did I use? Blue. So 1, 3, 4, 5, 6, 7, 8. Okay, great. Second picture with magnesium and zinc. These are the same masses, same original picture, right? So we've got 8 atoms here. This time, though, instead of showing the same number of particles, we're going to show equal mass. So this is going to have to be different number of particles. Okay. So again, I actually want to start with my reasoning. So if we have the same mass, because their molar masses are different, this is going to mean a different number of moles. Because molar masses are different. So this means that there's going to be a different number of particles. And again, because these are elements, these are atoms. Okay, so here's where we need to make sure that we're careful, is figuring out which one needs to have the most number of particles. Okay, if we're thinking about this, this is kind of be like a similar thought process that we had back at the beginning of the semester when we thought about density. So we've got zinc has a greater molar mass. Looking at zinc because that's what we're going to draw in. So this means that it's going to take fewer particles to reach 1 gram. Okay, so this needs to be less than 8 atoms. I'm going to represent this as 2 atoms of zinc. And I'm going to do that because I'm going to just kind of base this on a ratio between these masses. That's not really that important right now. Okay, but you definitely want to make sure that you have fewer than 8 atoms. Okay, again, because zinc has a greater molar mass, it's going to take less zinc particles or atoms to get to that mass of 1 gram, since each one is heavier. Okay. Actually, let's go ahead and add that in our explanation. Whoops. Because each atom is heavier. Okay, awesome. Taking a look at the back side, all of these questions go together, 5, 6, and 7. first thing, find the molar masses. These come straight from the periodic table. So I'm just going to plug these right in. Notice here that the unit is grams per mole, and that's at the top of the column. And that's the case, you do not need to place that on each of your values. So I know these off the top of my head just because I use them a lot, but these are 12.01, 40.08, 24.31, and 32.07 grams per mole. Okay, now that I've got that, let's take a look at number 6. We have an equal number of moles of each substance, and we want to match the diagram to the appropriate element, assuming density is equivalent, and explain our reasoning below. Okay, so I'm going to do what we did before, and I'm going to talk through our reasoning first before we match these up. Okay, so we know they have equal moles, which means they're going to have the same number of particles. Again, because these are all elemental substances that are monatomic, these are going to be atoms as our particle name. Okay, so we want to think about the size of our particles, our atoms, based on their molar masses. So remember, molar mass is in grams per mole, but this also gives us an idea of the mass of one single atom. Value is the same, unit is different. So if we look at these, okay, we've got smaller molar masses, larger molar masses. We want to think about which atom is going to be larger. Okay, well, it would make sense if the mass is greater, that the atom itself is going to be larger to accommodate that, and that's going to be true. Okay, so let's start with that. The larger the mass, actually the larger the molar mass, the larger the particle. So if we know they all have the same number of particles, but the larger mass gives us larger atoms altogether, we want to have the largest sample, the largest pile matching with that. Okay, so we're going to say, therefore, that matches with the largest sample. Okay, so if I scroll back up here so I can see my pictures and my masses, we're going to look for these molar masses, and I'm going to rank these. Let's go from greatest to smallest, since that's what I was just talking about. So greatest mass is calcium, followed by sulfur, followed by magnesium, and then the smallest one is carbon. Okay, we're going to match them up that way. Okay, so we're looking for our largest sample, and that's going to be our calcium, and that is the last one over here. Okay, second largest is sulfur. That's this one here. Third is magnesium, which matches up with the first picture, which means carbon is our second picture. Okay, great. Question 7, last one, is going to complete the diagram by adding particles to represent the atoms of the elements, and then explain our reasoning. So let's start with that reasoning. This one's actually pretty simple. We've back full circle back to question number 1. If we have the same number of moles, we have the same number of particles. Therefore, equal number of atoms. Okay, again, it doesn't really matter how many you choose to put in here. Just be consistent. And again, we want to make the size of our atoms kind of match up to those molar masses. I'm going to use 5 particles just because it doesn't really matter. Let me see here. I already used magnesium and calcium, right? Magnesium was gray before, so I'm going to go ahead and do gray just so I'm consistent. Let's see, I also used calcium, didn't I? I made that purple. So I'll go ahead and put purple here. Okay. Sulfur. Let's go with like orange-ish yellow, whatever color this is. And then carbon, last but not least. We want to make sure that this one is the smallest of these, and I'm going to go with pink. Okay, so we filled up all those particles. Again, it doesn't matter how many particles you use, but it does matter that they do have to be the same. All right, so that's the mold concept. If you have any more specific questions after checking the key and watching through this video, reach out to me or reach out to your individual teacher if that is not me. Thanks, and we'll see you again soon for more chemistry.